Okay, so welcome back. Picking up in part two of week two, we are talking about wired and wireless networks. So one special kind. So at home you'll have a router, and it'll also have antennas. So you know it's likely a wireless router, right? It will hook in wired, but yet provide you wireless communication capability. At work, you also have plug-in at the office, but you probably have what you see on the right, which are WAPs. That's a wireless access point, a WAP. And if you don't have either of those, say you're at the airport, you may want to create a hotspot, right? Or the airport, a lot of times will provide hotspots for free where you can get internet access. And I don't recommend using those because other people can be listening and watching your traffic on the internet in a wireless capacity. If you're in that case, and so a hotspot is a wireless network that provides these internet connections. So at home, your router can act as a WAP for a hotspot, the wireless access point. At work, it can also be a hotspot, right? But at work, you probably need a username and password to log in. The one on the right, we have Cisco devices, right? That's a common manufacturer of WAPs for these hotspots. Again, sometimes a password is needed to get on a hotspot. What I like to do when I'm at the airport is on my phone, my iPhone, I can create a hotspot by going into settings. And the advantage is that hotspot that I've created for my internet capability offers me a password, so nobody else is able to get on. It provides me a little more protection when I do my own hotspot. And when you use a hotspot, this is called tethering, like an old tether ball around the pole. I'm now connected where I was once not. I'm now connected, and that's called tethering. So if you need an internet connection, say at the airport, I always recommend you use your own hotspot and make sure it has secured with a password. Now, back to the internet service providers, right? We're getting this wired connectivity through internet service providers, again, such as Charter/Spectrum or Cox Communications, Comcast, somebody like that, right? It's a connection to the internet via broadband. And broadband does two great things for you. It allows for fast data transfers, and it's an always-on connection, invaluable, right? And so it can move tons and tons of data. We talk now in terms of megabyte, which is about 1,000,000 characters per second, or gigabyte, which is 1 billion characters per second. So it's really exciting where the whole industry is going. Okay, so then data gets processed, right? Now we have our internet service provider. We've got our internet connectivity, wired or wireless. So now data is that unprocessed item that computers have to put through a process, transmit, or store it in some fashion. So your internet service provider is both an internet service provider for your wired and an ISP for your wireless. And the whole purpose is to transfer this data, often done by cables like a coaxial cable or optic cables, which we looked at just a few slides ago. Or if it's wireless, of course, by radio waves or cellular signal or satellite signals are ways to do that. So basically what you do is in green, I've labeled these. I just took their notes and expanded them a little bit. So you'll send a request. Go to number 2, your cable modem is going to transfer that signal to your cable line, your wired line, which is super fast. That's broadband, right? That signal is going to travel to the central cable system. That cable system then is going to send out this signal high speed, your data packets that you just sent, right? And that's going to get routed through multiple routers from various different companies that allow it, right? They have to allow access to their router. Most of them do. There are exceptions. But they get routed and they reach the server or destination they're going to. So it's an email. It hits an email server, and that then gets transferred to the person that's supposed to get the email that's addressed to it. And any requested information, say you went out and you requested a website, that information would be then sent back to you. Okay? So that's kind of how that works. Now, to make this work, you need an IP address. An IP address is really just a sequence of numbers that uniquely identifies the location of each computer or device connected to the internet. That IP address will come with a domain name, which is text-based name that corresponds to the IP address. So there's a match. Every IP address will be connected to a domain name, all right? And you will use domain name servers to translate. So early on in the days of the internet, you used to have to type in the numbers of the site you wanted to go to. 149.17. Those days are gone. Now you type in Google, and your computer reaches out first to a DNS, a domain name service server. That's going to translate that name into an IP address, and boom, return it to your computer. You don't even know it's happening, and you're on your way. Okay, so this is kind of, right now we're using largely IP version 4 addresses. We'll talk about those more in a second. There is a new thing coming out with IP version 6 addresses. Well, let me just go ahead and discuss it real quick. So the IP version 4 address is 32 bits, and it's using 4 octets. Each octet, which is a name for 8, right? So they're basically 8 characters. We'll look at that in the next slide or two. But these 4 octets are separated by the decimals. So 74 is one octet, .125 is another octet, .22, .139. That's how we talk about it. IP version 6 is 128-bit internet addresses, which exponentially increases the number of internet addresses that are capable, right? We already talked, I think we've talked about a domain name, but a domain name is basically your website name. So a domain name is the address where the internet users can access the website. A domain name is used for finding and identifying computers on the internet. And these computers, of course, as I said, are using these IP addresses, which are these series of numbers, right? Like I said, it's difficult for human beings to remember these strings of numbers. So basically, we load in the domain name like Google, google.com pops up, we hit enter, and it goes off to a domain name server, a DNS server, to find the actual IP version 4 or IP version 6 address. A domain name is any combination of letters that can be used in combination with various other names. And they are usually .coms, .nets, etc. Now this next slide is referencing an IP4 version address. You see clearly it's about logic. And there are, I've laid out the 4 octets separated by decimal points in blue. And then each one has 8 different bits, right? So 8, 16, 24, 32. There's actually 32-bit structure in these 4 octets, each separated 8 bits each, okay? And each bit translates into an actual IP address, 128 at the bottom, .119, .64.5. And I'll show you in just a second how that translates. Well, I'll do it right now, in fact. So each one of these bits, you see the ones all the way across on the left-hand side? Each bit is associated with a capability, right? A binary form, 1s or 2s. So if I have just the far right bit, I've only got one choice, a 1 or a 0, right? I didn't mean 1 or 2s, I meant 1s or 0s. I've only got the one choice. But if I do the 1 and the 1 from the right, now I have several choices. I've got on and off for each, right? And so they frankly double. The third one will give you 4 options. The fourth one will give you 8, 16, 32, 164, and 128. So basically, no matter where I pick, so the second line on the left is only 128 bit. That would actually go in the corresponding IP address. It would be 128.0.0.0. The third one down would be, and this really can't happen, but 0.0.0.1, right, etc. And etc. So if you look to the right up top, there's an example, 172.16.254.1. That IP address, which your computer uses to communicate, is actually divided into those 4 octets. And to get 172, you see I have 10101100. Well, if you look left where all the ones are at, and you add those up, the first one is 128 bits, the next one is 32 bits, the next one is 8, the next one is 4. That adds up to 172. And that's how we get your IP address. I did another example down below, and you can look left and match those up. So for example, the first octet, which is 192, is, if you look at the ones at the top left, it's 128 and 64. That's where they get the 192. So that's really how an IP address is built. Not needed for the exam. I thought it was interesting, and some of you may enjoy that. Okay, this is just background. Also, for your background, IP version 6, I mentioned, is IP version 4 didn't create enough addresses. You know, we didn't think we'd ran out. Bam, we ran out. And it was divided into 4 octets or 4 8-bit groups. But now IP version 6 is called hexadecimal addressing, which are now 8 16-bit groups. And instead of divided by a period, they're each divided by a colon. That's enough on that. Not for the exam, again, just interesting information. Now we talked about domain names, right? So we don't have to remember the exact IP address. We can just go out and use a domain name. And a top-level domain is really at the very top of the structure, right? The .com, the .biz, the .edu. That's called a top-level domain. And so these are very popular ones on this slide that I show you. The book also addresses these quite readily. Okay, so one more slide on the when connecting about just the domain name service, and I've circled it in blue at the bottom. That's the focus of this. The DNS is really just like a phone book, right? It's a phone book for the internet. When I type in my domain name, like google.com or newyorktimes.com or something, the DNS is responsible for finding that correct IP address that we just talked about. And then it returns it to your computer, and off your packet goes, your data request, your data and information with the IP address, so that it gets routed through the network the proper way. And all this happens thanks to these DNS servers, right? Machines dedicated to answering these DNS queries. A typical DNS query servers work together to deliver this IP address to you, which we know is called the client in computer speak. Okay, which then ties us into the World Wide Web. Now I'm out there. I'm able to access the World Wide Web. We talked about this a little bit in chapter 1. It's that information system where all these documents, we call them web pages, right, and video files, but they're just documents. They're data documents out there for us. And so a web page has a unique web address, or we call it a URL for Uniform Resource Locator. And so really our browser, we open up our browser, that's our tool to translate the request. So we have this browser that's going to retrieve the web pages over the internet. It comes back to our computer based on our IP address. And because we're using the same protocol, which is a set of symbols to deliver and use the specific headings, paragraphs, images, our computer knows what to receive. Okay, we'll pick it up there again in part 3.